RNG stands for random number generation. This is a function that is called in code, which will give us a random number within a certain range. The main idea of RNG is pseudo-random numbers, which are numbers that are not random but seem random. Computers cannot just make a random number on their own. Instead, we settle on a function which can take in a number and spit out a seemingly random number. This means that any unique input will always give the same output each time. For say, if a 3 outputs a 5, then that'll always be the case. Now we can start with an initial input, which we call the random seed. We plug this into the function and we get a new number. We can use this output as a random number and save it for next time. The function is called. When we call it again, we use this previous output as the new input, which gives us a new pseudorandom number. We can keep doing this, generating a series of pseudorandom numbers. This also means that the seed determines the series of pseudorandom numbers, meaning the same seed will always produce the same series. Now we need to learn a little modular arithmetic. Let's say that we have 11 divided by 4. We want to get the result and the remainder. The result is 2 and the remainder is 3. Another way we can represent this is by going 11 mod 4, which is equal to 3. This is the same as 11 divided by 4, except we take the remainder and not the quotient. 4 in this case is called the modulus. The way that we use this for RNG is for shortening big numbers. This means that we can shrink the big numbers that we get from the main RNG functions into smaller, more manageable numbers by taking the mod of the output. The biggest remainder you can get is always 1 less than the modulus, and the smallest is 0. This means that the modulus is the number of unique remainders that can occur. So there are many different algorithms, formulas, and functions for generating a pseudorandom number, but they all follow the same ideas to a certain degree, which is generating varied numbers and not biasing certain outputs. They also give a large range of output values to avoid problems. The first problem with generating small numbers is that it is easier to end up with bias, especially after taking the mod of the output, which crams the outputs of the RNG into a small range, which can lead to bias towards certain remainders. The bigger the range, the more negligible these biases towards certain remainders become. The problem with small ranges is that it makes it much more likely for you to end up in a loop. Since the same input always generates the same output, if we manage to generate an output that we already have gotten at some point, we will find ourselves in a loop. Making the range bigger makes loops incredibly rare, and also allows us to have the option of bigger output ranges. One example of a random number generator is the linear congruential generator, or LCG for short. The LCG uses 3 constant variables and 1 for input. These variables can be set to anything, but programmers have found many different values which work well. These are some of them. I will not explain this as it is very simple yet effective. Just know that it will always give an integer between 0 and m. Now we will probably want the initial seed to be different each time, so that we don't have the same result each time. The first option is to set the initial seed to the time, which is what most, if not all, modern random number generators do. There is a different solution used by older video games which is really interesting. They do not have clocks in their old consoles, so instead they have to get their randomness from a different source, which is the player. For example, from my knowledge, the original Legend of Zelda for the NES used the number of frames since the player start of the game and spent on the title screen as the starting seed. Many older games also used input to spice up the seed during gameplay, by making each controller input change the next RNG input value in some way. Now you know how RNG works, and it is just a matter of manipulating the output to get the numbers you want. If you have any questions on how to manipulate the output for anything, or anything else, please feel free to ask. I would be happy to help. Goodbye.